My name is Ian Dennis Miller from the University of Toronto, and in this talk I will be discussing the cultural consequences of political unfriending, a computational simulation study. Let's say you woke up one day and noticed an old classmate was posting about the libraries again, and you're just tired of seeing it, so you unfollow. And from that point on, you won't see anything else they post, for better and for worse. Unfriending is a really interesting behavior to study because its consequences are potentially very long-lasting. When an edge is removed from a network, it is sort of like forgetting something. It's the opposite dynamic of an ant pheromone trail. Unfriending is also difficult to observe at scale, and it isn't typically visible through any API. Moreover, scraping approaches are aggressively throttled by social media platforms. Since it can be difficult to observe unfriending, I use agent-based modeling to generate synthetic unfriending. This work is a computational simulation in which we ask, what happens when we stop being friends and organize our entire society around politics? It's the downstream consequences that I really wonder about, and this simulation really picks up after the unfriending has occurred. We look at what comes next. A common definition for polarization involves opposite attitudes towards a topic, which is sometimes expressed as bias. For example, anti-library bias. But in this study, we say that polarization occurs when there is conflict about what to pay attention to and messages diverge. So, altogether, unfriending and polarization would amount to a systematic divergence of attention and message sharing among subpopulations. We will introduce a heterogeneity measure of population attention in a few slides. Here's the thing. I actually had some fun with this. It's a pretty big model, and it incorporates a lot of the phenomena I examined in my dissertation. But this time, I just threw it all in. The simulation includes multiple network layers and topologies, several agent types, and several kinds of information diffusion. So although I love an elegant demonstration of a principle, this work goes in the other direction to build a somewhat comprehensive simulated world. Introducing the town square. This is a NetLogo simulation in which agents perform a random walk while performing a set of information diffusion behaviors. The town square is a special region in the simulation because events happen here, and when an event occurs, all of the agents in the town square can see it. I'll say more about this in a few slides. Friendships are established at the start. The small world structure of this network is easier to see when the layout is changed. These are the same agents, but on the right they are laid out spatially, and on the left they have a force-directed layout. Agents can pass memes to their friends using the friendship network, similar to how they might with an online social network. Political networks are created before the simulation starts. When we change the layout, the organization of the parties becomes clearer. The agents are connected by edges that are color-coded by political affiliation. A hierarchical structure is created using a preferential attachment algorithm, which creates a few agents with high in-degree that will be designated as political representatives. These politicians gain the ability to make speeches that are broadcast to their political followers. Otherwise, agents can submit petitions to their representatives. So, beneath the surface of this simulation, there are several networks, political, friendship, and also a proximity network to support local diffusion. In the current work, the ability to turn these networks on and off is our principal manipulation, and it's how we can simulate a mass unfriending event. Other literatures might call this network intervention an exogenous shock. These agents constantly talk to each other about the events that happen in the town square. Events are witnessed by a few agents, then packaged as memes that can be diffused via sharing cascades. This dynamic is based on some of my previous work with memes and intention to share. I've extended this model with a mechanism for attention that interacts with message content, and repeated exposure to message features affects attention, so messages and agents change a little bit over time. Let's watch an example run. The action starts when an event occurs in the town square and several agents happen to witness it. First, they make memes about it, which are shared peer-to-peer. Eventually, there are petitions to political representatives, and then there are speeches, which are broadcast to all party members. Before I get into the results, I need to explain how we're measuring polarization. Each agent has a vector corresponding to the kinds of message features it will attend to. We can quantify polarization in terms of the heterogeneity of our agent's attention vectors, which we compute as the population cross product. When all agents pay attention to the same message features, their attention vectors are parallel. In other words, polarization is an emergent property of the simulation that only occurs when agents somehow become synchronized in terms of attention, and it turns out there are several paths to polarization. Here's the timeline for Study 1, the FRIENDPOCALYPSE. The simulation starts with agents distributed across the environment. Next, agents are connected via small world and preferential attachment networks. The agents perform a random walk, and events occur in the town square. Agents share recollection of events as memes, political petitions, and speeches, with gradual mutation. And this process repeats a bunch of times. Finally, after the agents get comfortable, we cut all the friendship ties. Here's a plot of petitions, speeches, and meme shares. We ramp up our simulation, and at this elbow we can see the point when all sharing stops. That's because we've cut the friendships. This moment corresponds to a sharp drop in heterogeneity, first in one party and eventually in the other. Ultimately, after a fixed amount of time, we record the final heterogeneity for the parties. We'll compare this later. Before I move on, I should mention that the simulation is pretty stable in the long term when friendship ties are not cut. However, before you start to think that friendship is the answer, I want to share a different simulation. Let's consider a scenario where the political network is built before the friendship network, which is what happens when people join a social network later in life. Initially, agents only talk to others in their locality or to their politician. It's not until we enable the friendship network that agents can easily share memes over long distances. And the moment the friendship network is enabled, sharing absolutely takes off. This moment also corresponds to an absolutely precipitous fall in attention heterogeneity. Heterogeneity actually recovers a bit and finds an equilibrium of sorts. However, this final heterogeneity value is even lower than before when we deleted the friendships. I compared these two scenarios by running each scenario repeatedly. It doesn't take too many simulations before there's a significant difference between average heterogeneity scores for each scenario. So, although I framed this talk in terms of unfriending, it's possible the more surprising finding is that the act of creating friendships in the first place could result in even greater polarization. In these simulations, when the aggregate attention vectors of each party converged, it meant the messages that were shared in one party would be unsuitable for the other party. So, in practice, this acts like a classic model of polarization. A related polarization-like phenomenon has been described for algorithm bubbles, in which people are exposed to a systematic kind of media based on their search history. Again, irrespective of the process, the outcome is similar, which is repeated exposures to a specific kind of message. Altogether, these simulations can be used to illustrate that there are numerous ways to achieve polarization, and unfriending is one of those ways. And is there a solution to polarization? Yes, most of the simulations I ran did not fall apart like this. As long as I didn't shock the system, it was all good. Thank you for your attention, and I look forward to your questions.